All right, we're going to start off by talking about how to graph rational functions. And what it means to be rational is when you have a function in the form f of x over g of x. So it's rationals, all that means is that these are polynomials and it's in fraction form. So now we're going to introduce something called a horizontal asymptote. And a horizontal asymptote, you may remember, horizontal is left to right. And so we would call a horizontal asymptote, that'd be this one right here. And so rationals sometimes have horizontal asymptotes. And remember, horizontal is always y equals. Now, we may also have what's called a vertical asymptote. And vertical asymptotes, those go up and down. And notice there's an asymptote here. And up and down is always x equals. Now what that means is we have our rational function here. This is going to come and it's going to decrease, 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 and it's going to keep decreasing forever, but it will never touch this asymptote. Okay, same here. It's going to come down, decrease, 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 but never touch the asymptote. So the asymptote is just a line or a spot where the function does never crosses that point. So vertical asymptotes, the easiest way to find the vertical asymptotes is to factor. So like here, it's hard to see the vertical asymptotes, but I have x minus 3 over x squared minus 9. Now you may remember x squared minus 9 is difference of two squares when you factor. That's x and x, 3 and negative 3, and you get this. And then you remove common factors. Those go away. And you put all that together, and you get that this equals 1 over x plus 3. Now all we're going to do is label asymptotes. So when is this? Well, what I usually do is the ones that cancel, we know that that makes a whole. Now the reason why I chose x equal 3 is because when I plug 3 in here, 3 minus 3 is 0, and you can't divide by 0. So the ones that cancel make a whole. Now the other one, that is what is called our vertical asymptote. So our vertical asymptote, again, what number plus 3 is 0? Our vertical asymptote would be at negative 3. So we have a vertical asymptote. Sometimes we label that as VA for vertical asymptote. Is x equals negative 3, and then there's a whole at 3. And I think it would help to show you a picture of the. All I did so far is I plotted the function we were just talking about. I want you to notice here at negative 3, we have what's called a vertical asymptote. And I'll show that visually. That's at x equals negative 3. I could scroll up. Let me make this dash to show that it's an asymptote. But I can scroll up forever, and this red line will never touch the blue line. Because the blue, the dashed one, is a vertical asymptote. It'll get closer and closer, but it'll never get there. Same thing here. I could scroll down forever, and the red will never touch the blue because the blue is a vertical asymptote. Now you may also see that I have what's called a horizontal asymptote. We'll talk about that in a second. But if you remember, we also said there's a whole at 3. So let's go look at a table. And let's see what the value is at 3. forgot to do the table for that. I have to click there. So let's see, 3, 4, 5. Oh, it's doing the blue one. We don't want the blue one. So I noticed. So when you're working with the table, I never noticed this before, but it doesn't know where to pull from. And so what I could do is I could just change that to an X and change that to a Y, because that's what the function is I was trying to pull from. And then when I plug in 1, oh, it's still confused because this is a function, this is a function. It doesn't know which one to make a table for. So I'll let that one be X2, and we'll let that one be just X, and it should plug in. Maybe if I put a Y2 and make that a Y2, there we go. So now it's pulling from here. So I got my X, and it's pulling the value from Y2. And you can see right here that at 3 it's undefined. And if you go to that point right there, see right there at 3 it's undefined. There's a hole right there. But it's really hard to see visually just on Desmos. All right, so we'll talk through a few more. I may not graph each of these. But here, if I were to factor this and factor that, here's what I would get. And then nothing cancels. So what number plus 5 is 0? That's -5. What number minus 1 is 0? That's 1. And so both of these are vertical asymptotes. Okay, so we have no holes, we just have vertical asymptotes. Here, so nothing simplifies. This does not factor. And so the only thing we have to worry about is the denominator. And so what number plus 2 is 0? That's -2. And since nothing canceled, we have no holes. So this would also be the vertical asymptote. Here, nothing cancels. So when is x squared plus 2 equal to 0? There's no way to ever get that equal to 0 in the real number system, because when you take a number and you square it, it's always positive. You add 2, it's still positive. So this one is an example of no vertical asymptote. Now we're going to talk about how do you find those horizontal asymptotes. And what you do is you look at the degree. And remember, the degree is the biggest exponent. So you look at the degree, it's 3 here. Here it'd be a 1. And so if the degree here is bigger than the degree here, then there is no asymptote that's horizontal. So anytime that degree is bigger than the other degree, there's no horizontal asymptote. And remember, horizontal is this direction. Now when I look at the degrees, if those are equal, like here, see degree is 2, degree is 2, then you can find the asymptote by dividing the coefficients. And what I mean by that, the coefficient would be 4. The coefficient here is 1. So I would divide those two, and I would get that my horizontal asymptote in this scenario would be y equals 4/1, which is just 4. So that's when the degrees are the same. And then the other option would be, what if this degree, which is 1, is less than this degree, which is 2? Well, anytime that happens, you know it's always a horizontal asymptote at y equals 0. Now here's some examples, and they walk through, and we've talked about step 5 and step 6. There's other things we could find. We could find x-intercepts, y-intercepts. Oh, we also found holes already. And you should know how to factor. So we have some examples here. Just to make the video shorter, I'll let you read through these examples yourself. A couple things. VA stands for vertical asymptote. HA stands for horizontal. And then I'll walk through how to find the x and y intercepts down below. And then also branches, that we call this a branch. So there's a few examples here. I'll let you read through those yourself. I would like to come up with some new examples. So here, what would be the horizontal asymptote? So we look, the degree here is the same. So when the degree is the same, what did we say? The horizontal asymptote is when they equal, the asymptote's found by dividing the coefficients of the terms with the highest degrees. So I do 4 divided by 1. So I would do the same thing down here. And I would do 2 divided by 1. And horizontal, remember, is y equals. So that'd be y equals 2 divided by 1, which 2 divided by 1 is just 2. Example 6. What's the horizontal asymptote? Do we remember what to do when the degrees are the same? When the degrees are the same, we, where's equal? Oh, they're the same. I should remember that. I just did one. You divide the coefficients. So again, 4 divided by 1. Horizontal is always y equals. That's 4 divided by 1, which is just 4. Now let's go through and identify some more asymptotes. Notice they have the verticals and the horizontal. So this is vertical, horizontal, vertical, horizontal. And they want me to circle what they are. So we're going to identify the asymptotes. And I'm going to start off with the vertical ones. And I'll do those in red. And it says you could use your calculator to graph, but I really don't need that. So remember, when I'm looking at vertical asymptotes, I'm looking, when is this 0? When that's 0 is when x is 0. So my vertical asymptote would be here. Because when that equals 0, you can't divide by 0. And I'll come back and do the horizontal asymptotes. When is this 0? Well, when x is 3. So I have a vertical asymptote at x equals 3. Now, if I had an x minus 3 up here as well, then those would cancel, and I would call that a hole, and it would not be an asymptote. What are the asymptotes for this function? So when is the denominator equal to 0? There isn't one. We could assume it's 1. So this one does not have a vertical asymptote. And in fact, it's a line. Lines don't have any asymptotes. So this one has no horizontal and no vertical asymptotes. When is this equal to 0? When x is 3. That's a vertical asymptote. When is this equal to 0? When x is negative 4. That's a vertical asymptote because it did not cancel with anything down here. Now let's go through and do the horizontal asymptotes. Horizontal, I'm looking at the degree. Now, this one's kind of suspicious because this is x to the 1. So technically, a constant has degree of 0. And down here is a degree of 1. So let's see, do we remember what happens when the degree down here is bigger than the degree down up here? So let's go look. And I always forget too, I have to go look. That's when that's bigger than that. When that's bigger than that, we have a horizontal asymptote at y equals 0. So going down here, too far, my horizontal asymptote is y equals 0. Same thing, this problem, this degree is 0, this degree is 1. So it has a horizontal asymptote at y equals 0. This one had no asymptotes. Again, the degree here is 1, the degree here is 0. So horizontal asymptotes, y equals 0. Now here they're the same degree. You got 1 and 1. And when they are the same, remember, you divide those two numbers. So I would take 3 divided by 1. So y equals 3 divided by 1, which just reduces to 3. So for this one, the horizontal asymptote is y equals 3. Okay, this video is about 15 minutes. I do plan to make another video where I'll go through these 3 examples, actually 4 examples, but I'm going to go ahead and hit stop for now. That way you can have at least the note portion.